Hello, and welcome to the Cisco Support Community's Expert Series webcast on Border Gateway Protocol, BGP, Fundamentals, and Troubleshooting. A few housekeeping notes to begin. As we enter the WebEx console, you either join us via audio, broadcast, or by the phone, which was automatically muted. Because our large audience in attendance today, you will remain muted throughout the event. When you have a question, please feel free to enter it on the WebEx Q&A panel located at the bottom right corner of the console. Please leave the chat window available to communicate with the WebEx facilitator for any problems or issues you may experience today. We will appreciate your feedback on today's event by taking the short survey after appears when you close your browser at the end of the event. My name is Monica Lewis. I am the Communities Lead for the Cisco Support Community, and I am the moderator of today's event. The Cisco Support Community is an online forum with over 500,000 members where you can get answers to your technical questions prior to opening cases with a tag. You can answer many questions or contribute and rate documents, videos, and blogs. The community can help you boost your career by becoming a top contributor and getting the technical community to know about your expertise. We invite you to use the community on a daily basis at supportforums.cisco.com. We have you as the experts and webcast events that will be posted at the events area in the support community at the link posted in the chat. If you haven't already done so, please be sure to join the Cisco Support Community where you can share current real-world technical support knowledge with your peers and experts. Check out the class of the new 2016 Cisco Designated VIP and the Spotlight awardees on the Cisco Support Community. If you are interested in conducting an event for us and becoming a top event contributor yourself, just submit a form to the Experts Bureau at the link in the chat. Take a moment to rate the content of your peers' documents, questions, videos, and blogs. In doing so, you will help us recognize the wonderful content that they contribute. Ratings encourage contributions. You can read about more about the ratings on the Cisco Support Community in the link located on the chat. Now, on to today's presentation. Our expert joining us today is Vinit Jain. Vinit is a technical lead with the Cisco High-Tech Technical Support HTTS team supporting customers in areas of routing, MPLS, TE, IPv6, and multicast. He also supports a wide variety of platform issues such as high CPU, memory leaks, Cisco iOS, iOS XE, and iOS XAC software, and NXOS code base. He has delivered training and Cisco on various technologies as well as platform troubleshooting topics. He has also written a workbook on Cisco iOS XR software fundamentals on the Cisco Support Community. And he has done a lot of events for the Cisco Support Community. Vinit has expertise in troubleshooting service providers, enterprise and data center environments, and holds a CCIE in 4 areas: routing and switching, service providers, data centers, and security, as well as multiple certifications on programming and databases. He is giving a presentation on BGP at Cisco Live Berlin, and if you are attending the Berlin session, check out his breakout session that he's going to deliver on February 19. And the link of the breakout session is in the chat. We also have 2 experts from Cisco joining us today to help out with the technical questions that you will be asking. Is Brian Dunn and Manish Kumar. Brian is a technical lead in the HTTS team and is an expert in routing protocols. Manish is a customer support engineer, also expert in routing protocols, and he holds a CCIE in routing and switching. Vinit will continue with the discussion in an Ask the Expert event now throughout January 22nd. So if you have more questions after this webcast, please visit the events page on the Cisco support community or reference at the event in the chat window. He will continue answering questions until January 22nd. If you would like to have a copy of the slides, please click on the link on the chat to download the PDF version of the slides. And then we will be recording the presentation and it will be available as soon as we are able to process it. So bookmark the URL on the chat window where all the presentation, the live Q&A, and everything will be ready for you by the end of this week. For today's Expert Series webcast, our expert will start with the presentation and then we'll dive into the live Q&A submission for the remainder of the event. During our live presentation, you may submit questions for Vinit to answer using the Q&A box on the bottom right side of the console. We will be selecting these questions that Vinit will answer verbally at the end of the presentation. When the webcast ends and you close your event, please take out the survey and let us know how you rate this event. Now, let me pass the mic to Vinit for him to start the presentation.
Thanks, Monica. Guys, I believe Monica has already introduced me, so I don't need to introduce myself again. Today we'll be talking about BGP, Border Gateway Protocol. If you are already familiar with the protocol, this is a good refresher session. If you're not, then it's a good startup session for you. I have tried to cover some good basic topics related to BGP and also some troubleshooting scenarios based on those topics so that you not just understand the protocol, but you also understand how you troubleshoot when you get into some problems with the protocol. Right. So beginning, we'll be having the following as the agenda. So we'll be covering the refresher, how BGP neighborships are formed, how the prefix advertisement happens. So between the two peerings or multiple peerings, how the prefix are advertised and how they're processed. We'll be covering that. How you filter the prefixes, because you don't want all the prefixes to be installed or to be available to you. So how do you filter them? And we will see how to use BGP communities. And based on this, we have two scenarios wherein we'll be seeing how to troubleshoot BGP peering issues and missing BGP routes. Well, these two troubleshooting scenarios are basically a sneak peek of my Cisco live session. It's a very small part of the session, but still you'll get a feel of where we are starting with it. All right. If you have any questions, please feel free to post it on the Q&A panel. And if I'm not able to answer all the questions today, there's the Ask the Expert event, and you can also post your questions on Twitter or Facebook. I'm pretty active on the support forum as well. So if there are questions anywhere, I'll try to answer as much as I can. All right, so let me begin with the polling question. Do we know how much or how big is the internet routing table? You have four options, right? 250K, 500K, 400K, or 600K, approximately. So you have some time to answer these questions. I believe you have 5 minutes. So I'll come back to this question later on while you answer this question. But the reason I'm asking this question is it really depends on which protocol you use to manage the internet routing table, right? And we'll get to that later on. All right, so the refresher. BGP was defined in RFC 4271. It's a path vector protocol, which means it relies on the path that it is following, or a prefix is following to reach to its destination, right? And where exactly it is being advertised. So you have 10 hops, and there are multiple connections between those 10 devices. You may follow different paths, and based on the paths, one of the paths is selected as the best, and best route is available to you. So it's generally called a path vector protocol, which is highly scalable and flexible. So you can manipulate the various attributes, and you can control which routes you want, which routes you don't want, and stuff like that. Pretty much the same with what you can do with IGP, but you have more scalability and flexibility as compared over here. Right. BGP was primarily designed for inter-AS autonomous system connectivity, though you can use it within your autonomous system, but it depends on what is the purpose of using it. But when you want to interconnect two different autonomous systems, you use BGP. And based on certain agreements between the two, say for you have a service provider, and you are taking a link or an internet connection from your service provider, and you are using a protocol, say BGP, and you have been assigned an autonomous system number from INA, and you have your service provider running its own autonomous system number, and you use the pairing to exchange the routing information from your service provider based on your requirements. So that's where primarily the BGP use comes in, but the BGP over the period of time has expanded, and it's not just for inter-AS connectivity, but intra-AS, and it also extends itself to various other edges families. So now you can have peering for IPv4, IPv6, VPN-v4, which is basically used for MPLS VPN scenarios, VPN-v6 as well, which is for 6PE or 6VPE. So MPLS VPN for IPv6, you can say, MDT or L2 VPN. So you can not just have MPLS L3 VPNs configured via BGP, but you can have the control plane running for L2 VPN as well, which was earlier not possible. It came later on with new RFCs and developments. Now, with BGP, most of the time it deals with attributes. Now, what are attributes? Attributes are associated with every prefix that you have advertised in your BGP environment. So there are four kind of attributes, which are actually divided into two categories: well-known and optional. Well-known, you have mandatory and discretionary. So mandatory means even if you don't assign any attribute, those attributes will still be present for any prefix that you have in BGP table. Those are the mandatory. And what are those? Those are AS path, origin, and next hop. It's mentioned in the notes section for your reference. When you download the slide, you'll have that information. But there's also a link in the reference section later on, which you can refer and get that information. Discretionary are the ones which may or may not appear in the update message. So an update is coming from a BGP neighbor, and that update might have some information or some attribute attached to it, or might not have. Those kind of attributes are called the discretionary, and basically those two attributes are local preference or atomic aggregate. Right? Then you have optional attributes, which are transitive and non-transitive. Transitive attributes are those, say for two BGP peers are communicating with each other, but two different, both of them are having different capabilities. So one router is having a capability of X, whereas other one is not having. So what happens is when I send an update to the peering router and it doesn't understand that attribute or capability, it doesn't do anything with it. It just forwards it to the next hop, to the next BGP peer, right? With non-transitive, it doesn't forward those if it doesn't understand it. So what are the transitive attributes? So transitive, you have like aggregator, and you have community values. And for non-transitive, you have MED, multi-exit discriminator, or you have originator ID and cluster list. Cluster list generally comes into play when you have route reflectors configured. We'll get to that in a moment. In BGP, IGP has various, like EIGRP or OSPF has its own loop prevention mechanism, right? Using their own set of algorithms. With BGP, you don't have an algorithm. You have AS path doing the prevention of loops in your environment. Means if you see your own AS number within the path, you ignore that route. So for any reason, that route doesn't cause any kind of loop for the traffic in the network, right? So the algorithm is actually based on path selection, not based on a particular route. It's based on what AS number you have. Okay. So for route propagation, any packet or any route received from an eBGP neighbor. So eBGP neighbor is peering between two different AS numbers. And IBGP, that is internal BGP, is peering between two internal neighbors. So say for you have AS100 peering with AS100, it is called IBGP. AS100 peering with AS200, it's called eBGP. Okay, so what you have is you can have a route advertised from eBGP neighbor, which can be advertised to IBGP neighbor or any other eBGP neighbor. But you have an IBGP route, you can advertise it to eBGP neighbor, but you cannot advertise directly to another IBGP neighbor. If you want to advertise your internal BGP routes, IBGP routes, to another BGP neighbor, you need to have either a full mesh or you need to use features like route reflector or configurations. What route reflector does is like you say that my job is only to reflect what you're sending me. So you don't need to have full mesh connectivity. So say for you have 4 routers, A, B, C, and D. For full mesh, you will have to have peering of all the 4 routers with the rest 3 of them. So A needs to connect to B, C, and D. B needs to connect it to A, C, and D, and similar so and forth, right? So to avoid such scaling environments or complex full mesh topologies, route reflector solution was proposed, and that helps overcome this challenge, right? And similar with the case configurations where you have multiple ASs within the top level root AS, you can say. BGP can hold almost the whole internet routing table. Now, I see the question being answered by a lot of folks. The answer to D is the one. 102 people have answered out of 383 to option D. Now, option D is near about approximate 600,000 routes. That's near about what our present BGP internet routing table is looking at. Well, it passed 512 already last year. So we are way ahead. Okay, so BGP can hold the whole internet routing table. So what it does is, there are 2 different kind of tables when you're running BGP. You have your normal routing table, which we call the RIB, RIB, Routing Information Base, and you have the BGP table. So all the information that you receive from your BGP peers are stored in the BGP table. They are then processed and downloaded into the routing information base, that is the routing table. And based on the routing table, you make your forwarding decisions. So all the forwarding happens based on your routes present in the RIB, not based on just the routes present on the BGP table, okay? All right, so eBGP route advertised to IBGP peer. Next hop, I'll show this next hop. Regarding this point, I would say just hold on to an example that I have for you, because you will understand this concept in a much better way when I show you in a live example. Okay, with BGP, there are basically primarily 4 messages. Route refresh is a different capability because of which a new message was introduced and that is advertised. But by default, you have 4 messages: open, update, notification, and keep alive. Now, open messages, when you open your communication, update messages when you are sending an update to the peers. Notification is when you receive an error from the remote peer. So you send a notification. When you receive an error, some information that you cannot understand or your router cannot understand, you say a notification, say, I don't understand this information and I need to drop the session. or do XYZ action based on what needs to be done. Then we have keep alive. Now, there's a keyword with keep alive. Generally, keep alive are used to keep a track of if the BGP or if the session is alive or not, right? If the session is not alive after the keep alive hold timer expires, the BGP session goes down, right? But here's the thing. When the BGP updates are being sent or exchanged, the router does not need to send the keep alive message. It will only send the keep alive when the update message are not getting exchanged. So if, say for some time, the update message didn't get exchanged, so keep alive will keep sending its messages after a certain interval, by default 60 seconds. But for some reason, updates are coming in, so the keep alive message will not even trigger at all. So you don't have to worry about it, right? Important thing with BGP is you need to have the next hop reachability. If you don't have the next hop reachability, the routes will not get installed in the RIB. So you will have reachability problems within your BGP environments. And we'll see how that happens. Okay, so before we move on how a BGP neighborship is established, I would show you how to configure it because I planned that out to have a demo rather than showing the configuration on the slides. So let me share my screen. And let me know when you can see my desktop. Is the desktop visible? The secure security window?
Yes, we can see it.
Okay, perfect. So I am simulating this in Viral, or you can have a CML, which you can download from Cisco.com or purchase it. And that's really helpful if you want to simulate different environments with iOS, ISXR, or Nexus OS. It's similar to what you have in GNS3, but it supports multiple platforms, multiple code bases. It doesn't perform hardware-based forwarding, but only control plane features can be tested. All right. So we have R1, R2, and R3. We are running IGP between R1 and R2. And this is R2 and R3. We are not running any IGP. We're just having a plain link IP configured. So I'll show you. Show IP OSPF neighbors. This is ISXR. So how do you configure BGP neighborship? I'll show you the configuration of both iBGP and eBGP neighbors, right? Router BGP 100, BGP router ID. It's a good practice to configure BGP router ID, but even if you don't configure it, the BGP session will still come up. So the remote is 1.1 BGP router ID. Once you configure it, okay, let me do this. Let me go to iOS router first so that you are much familiar with that one. And then let me come back to ISXR and show you what the differences are, okay? Router BGP 100, BGP router ID 192.168.2.2, right? Neighbor 192.168.1.1, remote AS 100, okay? Neighbor 192.168.1.1, update source, loopback 0. So first we define what is the peering remote AS number, and then we say what is the sourcing interface. Now, if you don't specify the sourcing interface, by default, it will take the outgoing interface. So whichever link it's having a reachability, it's going to take that interface as its source. But if you're peering over the loopback interfaces, which is a much better way and more reliable way because loopback interfaces don't go down automatically, and it can be reachable via different paths. If you have multiple paths within your IGP environment, that really helps, okay? Address family, IPv4 unicast, and you say neighbor 192.168.1.1, activate, okay? All right, so here we do it differently on ISXR. What we do is you have to configure the address family first, okay? You enable the address family, and then you configure the neighbor. So you say neighbor 192.168.2.2, and it's hierarchical so that you don't have to put everything in line. You just configure the neighbor, and all the subsections will lie under that. So you say, yeah?
Sorry to interrupt you. Your computer is not refreshing. Can you unshare and share again?
Oh, okay.
Please?
I'm sorry about that.
Sure, no problem.
Is it looking better?
Yes, thank you.
Okay. Hey, sorry about that, guys. Update -source loopback 0. And once you have updated that, configured both the remote AS and the update source interface, you specify the address family IPv4 unicast because that's what you have enabled. And you say nothing. Right now, you don't need anything. If you want the parent to be formed on different address family under the same neighbor configuration, you can configure another address family, VPN v4 unicast, right? But note that it will not work because we don't have that configured here. We don't have that enabled here, right? So let me commit it and see what happens. All right, we got an error. Now, why we got an error? Because we enabled an address, configured an address family, which is not supported. So show configuration failed, and it would say not configured, has not been initialized. Okay, so just wanted to give you a heads up on how you configure it. So you disable that and you say commit, and you will see that the BGP neighbor will come up. Show IP BGP summary. Okay, so we have our iBGP session up. Okay, and then for configuring an eBGP session, you can configure the neighbor IP.
Hey, Vinit.
Yeah?
Sorry, but your screen has stopped refreshing again.
Oh, I guess there's a glitch. But anyways, I'll show you the configuration again. Shouldn't be a problem. Yeah, it's something to do with when I change the tabs. So just to show you guys, show IP BGP summary will show you when the session comes up. Okay, and you will get a notification, a message that the session has come up. Fine. So this is how you configure a BGP session. All right. So when coming back to the slides, when a BGP session is established, it goes through multiple states, wherein you have a connect, then it goes to an open sent, open confirmed, and then into established state. Well, the BGP session actually starts with the idle state, where it's an initial state and listens for a new connection from the peer. Okay. When it is in connect state, what happens is it says that it has received an open message from the peer. Active state is when it says that it starts the TCP session establishment. Okay, and when you have an open send, it's that when you have the open message send and waiting for your open message from the reply from your neighbor, and it is when you make the checks on the BGP version, the source IP, AS number, and all that stuff. Once you have the open confirm, BGP waits for a keep alive or notification, and if everything goes fine, you move to the established state. Okay. Like I showed before, show IP BGP summary is the command that you execute to understand if or which neighbor has been established. If you are not seeing a particular neighbor established, rather than seeing a numeric value over here, you will see the state in which the session is in. It might be in idle state, it might be in active state, or any other state. Okay, but not showing a number. When it's not showing a number, means it's not in established state. Okay. A few fields that are part of this output that you need to look on is the neighbor. So it will show you the neighbor IP, AS number, Table version is how many updates you have. I mean, how many updates you have received, and based on how many updates you have replicated onto the BGP table. It's useful when you're troubleshooting some flapping routes issue, right? I'm sorry, I'm not covering that today, but you can have that from my Cisco Live website. Oh, sorry, slides. Input and output queue, those are the queues that are maintained by the BGP on an upgrade group or on a per neighbor basis, which holds the messages that are being sent to a particular neighbor or to an update group. Okay, the state, and then you have the state and the prefix, means how many prefixes you have received. You can look at the number of, when you execute this command, you look at the number of prefixes received from the neighbor, not advertised. Now, how the advertisement works. You can advertise the prefixes in BGP using 4 different methods, right? The first and the most used method is the network statement, right? You put the command network, the prefix, mask, and the subnet. So if you're putting an exact prefix, use the exact mask. Say for you are putting network 192.168.1.1, put the mask of 255, 255, 255, 255. But if you're putting in subnet of 10.1.1.0, then you put a mask of, say if it's a /24 network, you put a mask of 255.255.255.0. Okay, that's how you do it. When you are running 2 different protocols and you're in redistributing, like you do it in IGP as well, using redistribution, you can redistribute your IGP length routes into the BGP table and vice versa. Okay, you can summarize the routes. Summarization occurs using the command aggregate address. Using this method, you summarize a bunch of routes, say for 2 or 3 subnets, into a single prefix or subnet, and advertise it to the peer, so that this helps in reducing the size of the BGP and the routing table. Okay, if you want to advertise a default route, you can use default information originate command. Okay, so we'll look at how the prefix advertisement works. So if you look at the router 3, right, you have show IP BGP 3.3.3.3, and you configure the network statement, right? Network 3333 mask 255, 255, 255, 255, and you see that in the local BGP table on R3 on the right-hand side, you have local as 0.0.0.0, means it is advertised locally. Okay, if you go to the left-hand side of the output on R2, you will see that the next hop information is shown as 10.23.23.23. So the next hop value is what we have for our eBGP peer, what we receive from the eBGP peer. It is not changed, right? What you're advertising towards the neighbor, you can use the command show IP BGP neighbor IP and advertise routes. So you can see a list of prefixes that you're advertising to a peer. It can be an iBGP peer, it can be an eBGP peer. You can use either in either direction to understand what routes you are advertising to your peer routers, right? If you want to know what you are receiving, you can use show IP BGP neighbor IP, and routes command. We'll see that in a bit. Okay, so route filtering. Now, route filtering happens again with 4 different methods. You can use distribute list. I am pretty sure a lot of folks are already familiar with the distribute list in IGP that you use. You can use prefix list. You can use filter list, and you can use route maps. Right? Each of them have their own use cases, but if you want to choose between an access list or distribute list and prefix list is more optimized because for like example with ACLs, you go in a sequential way, right? You don't have to do that in the code for prefix list. So that is more optimized, and it's better to use prefix list rather than using a different method. If you are working with different neighbors, route maps and multiple policies are being applied, it is very useful to use route maps because you can control what to permit, what to deny, what options or what attributes to set, what to match. You have more flexibility with route maps. Okay, so here's another example wherein we can see how we can attach an attribute to a particular prefix or what we are receiving from the neighbor. So if you look at the router to configuration on the right-hand side, right, by default, let me tell you this, by default, the local preference, the attribute has a value of 100, okay? But we can change that to manipulate the flow of the routes or the prefixes. How we can do that? On the router 2, you configure neighbor 10.23.23.3, which is the eBGP pure IP, right? Route map, name of the route map, and in direction. Local preference is always configured inside direction to influence the outbound traffic. Okay, local preference configured on inbound direction to influence the outbound traffic. So if you go down the configuration, you can see we configure a prefix list and match a particular subnet IP. So you can have your attributes set on certain prefixes, not just the whole prefixes being received from the remote end, right? So in the route map, we say route map local preference permit 10, match the IP address, which we defined in the prefix list, and set the local preference to 200, right? Now, if you see the output on the left-hand side, the initial output, you can see that the local preference is set to 100. So show IP BGP 3.0.0.0, it's another subnet because we are only setting the local preference on 3.0.1.0/24, right? So if you look at the second output, show IP BGP 3.0.1.0, you can see that the local preference value is 200, okay? So this is how you can influence different attributes and influence your traffic accordingly. So if you have multiple links between the two neighbors or between multiple neighbors and you want to prefer one link over the other, you can use these attributes to influence your traffic outbound or inbound. Okay, there are different attributes using which serve different purposes. So we are back onto this policy influencing the traffic. So outbound policies. So the policy, if you see in this configuration, we configured the route map in the in direction. We can configure the route maps in out direction as well, but those outbound policies will influence the incoming traffic. And what we configure in the inside direction, inbound policies are used to influence the outbound traffic. That is the traffic going out of your AS. Okay, so what all different attributes you can use? You can use weight, local preference, or community values to have more control or what you want to send, what traffic or which link you want to have your traffic flow through, right? So in a way, you can say that with BGP, you can really, engineer your traffic the way you want to flow between ASs, right? Which you really cannot do so easily with IGPs, okay? With outbound policies, you can use AS path. You can use different other attributes that are supported to influence the incoming traffic, okay? Now, BGP next hop example. This is what I was talking about earlier in one of the slides where I said, let's hold on to the thought over here, okay? So let's see what is happening here. Now, let's take an example of just router 1, router 2, and router 3 in the topology that we see here, okay? In this topology, if you notice, R3 is advertising a prefix set of 3.0.0.0/24, 1.0/24, 2.0/24, and so on, right? When it advertises, and like I said before, eBGP routes can be advertised to iBGP neighbors as well, right? So router 2 receives the route in its routing table. in its BGP table, not routing table, BGP table, right? In the BGP table, you look at show IP BGP, or you can also use show BGP IPv4 unicast. This command will show the routes or the prefixes present in the BGP table. Okay. Now we can see all the 4 prefixes are present in the BGP table, correct? And we can see the next hop value. Like I said before, since there are 2 paths over here, you will see one path via 10.45.45.45.5 IP and one path via 10.23.23.3 IP. Okay, and one of them will be chosen the best based on a certain criteria. Well, the criteria is I have put a reference slide which tells you about how the best path selection happens, because that will really help you understand why a particular route is being selected as the best and installed in the routing table. Only the best routes are installed in the routing table. Not all routes are installed in the routing table. So you may have 10 different routes, but only 3 of them are selected as best. Only 3 of those routes will be installed in the routing table, not all of them. Okay. Now, if you look at this, here, the arrow mark indicates that this route is selected as the best on router 2, show IP BGP 10.23.23.3. Okay. Now, when we go to R1, we cannot see that prefix in the BGP table. So if you do show IP route, the routing doesn't have that information. Show IP BGP 3.0.2.0, we see the prefix in the BGP table, but notice that you're seeing 10.23.23.3 inaccessible, right? So what you can do is, when you see such kind of things, try to ping this IP from R1. So if you ping 10.23.23.3 from router 1, you will not be able to reach that. The ping will not go successfully. The reason is router 1 does not have this IP or the subnet in its routing table, and it says it has become inaccessible. I cannot access it. So what do? I make the prefix inaccessible, and none of those prefixes will be selected as the best. Like I said before, next hop reachability is important, and if the next hop reachability is not there, those prefixes will not be selected as best and will only remain in the BGP table. So no traffic will be forwarded out of R1 towards those prefixes. Okay. What you can do, either there are 2 solutions. What you can do is you can redistribute on R2 the subnet 10.23.23.0 into IGP, the OSPF that you're running between R1, R2, and R3. You can try configuring a network statement. You can try configuring redistribute connected to have that advertised into the routing table, and that will have the information to R1. But what is a better solution? Because the redistribute method will increase your routing table size, which we don't want. What we can do is use this method, neighbor IP, next hop self. You configure this command on router 2. What it does is says that in order to reach this prefix or the prefix that I am advertising to you, which are probably eBGP neighbors, I am the next hop because I know how to reach that destination, right? So when you advertise this or configure this command on R2 and R4, you can go back to R1 and see the prefix show IP BGP 3.0.2.0, and you will notice that the next hop value from 10.23.23.0 has changed to the loopback address of R2 and R4 respectively. And R1 knows how to reach that because it is forming an IBGP neighborship on those loopbacks, and at the same time, it is running IGP to have that loopback information. So it's having the route present in the routing table. Okay. So this really helps with a single command. You can save a lot of resources on the router by not having to redistribute multiple routes in your BGP table and your IGP table for sure. Okay. So now, like I said, AS path also is used to influence the traffic. The smaller the AS path, the highest preference a particular path gets. So if router 1 has 2 paths to reach to R3, one is via R1, R2, and R3, another one is via R1, R4, R5, and R3, right? But what you can do is, since R1 to R2, R3 is a smaller path, that will be preferred because it doesn't have any, it's just two ASs, AS100 and AS200, or different AS numbers that are configured here. Those are private AS numbers. So apart from those, you can influence the routing by prepending the AS numbers. What you do is you configure a route map and say that set AS path prepend. What it does is, on top of your own AS number, it also prepends the AS number that you have put in the route map. So what it does is it actually makes the AS path length a bigger one. So a particular neighbor, so here neighbor 10.23.23.2 is saying that prepend these 3 AS numbers, right? So the AS path has increased by 3 more, right? What it will do is it will make the path preferred via R4 because that is not having such configuration. The other path is being learned via 65534 and 3 more iterations which we prepended. But the path via R4 is having 65534, just 1 AS by default, right? So that becomes the best route. So this is another example how you can influence your routing or your traffic forwarding, okay? And how do you validate your prefixes? Like I mentioned before, you can use show IP BGP neighbors, neighbor IP, and the routes command that will show you what you have received. And show IP BGP neighbor IP advertised routes that will show you what you have advertised. Right? So you can use on either of the iBGP or eBGP neighbors. All right, so this is what I had for theory section from the refresher point of view. Here's a quick question, a polling question for all of you. Which protocol would you prefer for carrying internet routing table? I believe most of you might have the answer, but I'm still looking forward for your feedback on the polls. Okay, let me move forward and we'll come back to the polling question. It's a very simple question. I haven't made it too complex, but based on what we have learned so far, the challenge is coming in the next section. Okay, so we all will be, troubleshooting some scenarios and certain things to see how we can troubleshoot BGP peering issues or failed or missing routes. Okay, so you suppose you're configuring an iBGP or eBGP neighborship, and you notice that your sessions are not coming up, or maybe your sessions were fine, working fine before, and now the sessions are not up now. I mean, they're just down. What do you do? Right? So you have various steps that you can follow to understand where the problem is and how you mitigate that problem. Okay. Always start by looking at the configuration. Be it iBGP or be it eBGP, it is always important to look at the configuration, right? If you are having multiple hops between your eBGP neighbor, so let me give you a brief more overview on how eBGP works, right? Generally, eBGP is between 2 routers. By default behavior, we try to set it up between 2 directly connected routers on a physical link in most of the scenarios. In that situation, the default behavior of BGP is it sends the BGP packet with the TTL value of 1, right? So that's how those packets reach to the destination and the BGP sessions are formed. But when you're trying to peer it on your loopback addresses, or if you have multiple hops between your router, your 2 routers, say for router 2 and router 3 is having another routed firewall between it, right? Or it may be having another router in between that, right? I'm not talking about a layer 2 switch because it's not really counted as a hop because you're directly connected still at the layer 3 level. If you have a routed firewall or a routed node or router, in that scenario, you have an additional hop to reach the destination. So in that scenario, you will need to have eBGP multi-hop command configured, right? So if you are having eBGP neighbors over loopback to loopback, you will need to configure minimum of eBGP multi-hop 2. If you don't configure the hop value, it will by default take 255, and it will accept any value from 2 to 254 as a TTL value, okay? The second step you do is, when you're troubleshooting BGP issues, you look at the reachability. If you don't have reachability to the peering IP, that's the problem. But notice, if you're peering between loopback to loopback, always perform the ping test sourcing the loopback. If you don't do that, that means if your loopback to loopback reachability is not there, your session will not be formed. So you need to ensure your loopback, your IGP is configured properly, or you have your static routes, if you're using static routes, configured properly to have the reachability on both sides. If you don't have the reachability, your session is not going to come up. The third step you do is verify any ACLs in the path. If you have a firewall, right? Most of the enterprise environments does have firewall implemented to protect from outside intruder traffic or any IPS solutions to prevent from any viruses or any kind of attacks, right? In such scenarios, you have ACLs configured, or you might also have another routed node wherein you still have your ACLs configured. Route is working like a firewall to prevent certain traffic you don't want. So ensure that you have proper entries to allow BGP traffic. If you do not have ACLs entry to allow BGP traffic, and specifically for the neighboring IPs, the session will drop because the node in the middle will drop that traffic, will drop those packets, and it will not make it to the either side. So one side you may still be able to send it, but the other side packets you may not be able to receive it. The fourth step is verify using a TCP session. So we know that BGP works on TCP port 179, right? So what you can do is, if your session is not getting established, you have verified your reachability is there, you have verified your firewall entries are proper, and your configuration is perfectly fine, you can do this test, right? What you can do is telnet to the destination interface, or the destination IP, and port number 179. If you are peering using a loopback, do specify the source interface loopback 0 or any other interface for that matter. If your destination is not reachable, right, that is a problem. If this is another way of verifying that TCP traffic is getting blocked somewhere. So sometimes what happens is you have two different sites located at two remote locations, and you are being provided service by your service provider, right? Your service provider provides you a link on both the sites, and it's blocking certain traffic. Using this telnet method, you do not have control over the service provider network, so what do? Using this method, you can actually confirm if the traffic for the TCP port 179 is being blocked or not. This is really helpful. Well, in IOSXR, I'm not sure how many folks on the call on the WebEx today are familiar with IOSXR, but IOSXR is a distributed platform. So every routing protocol, every feature has its own set of process and threads which are working for that processes performing different tasks, right? First thing, you need to ensure that your process is in running state. So when you do show process BGP on IOSXR, you should see the state in running state, okay? And look at the threads. The same command will show you at the bottom, there are different threads. Look at the states of the threads. If it's something other than receive or mutex, like here in this case convar, which means conditional variable, it's actually dependent on another process and another process is actually blocking it. You need to understand why it's blocking, and further troubleshooting is required from that perspective. If certain processes are blocked or are not available or they are busy doing something else, your BGP session can be impacted. And not just one, multiple BGP sessions can be impacted for that matter. So always use the command show processes blocked. This will give you an idea of how many processes, and especially if TCP related or BGP related processes are blocked. If they are blocked, you need to figure out why, or maybe open a attack case and they can help you figure out why it's blocked. One of the most important tools that during troubleshooting over the past few years we have experienced is Sniffer captures. Sniffer, though it's a last resort for us, because if you're running out of options, Sniffer is the best way to deal with the problem, to understand where the packet loss is happening or if any of the devices is actually sending a packet or not. I wouldn't really recommend running debugs in the live production environment because a lot of services might be running into on the router, and it is not good practice to enable some high impacting or high CPU utilization debugs, right? So what you can do is you can have Sniffer captures, like you have Wireshark software. You can install it on a laptop, connect your PC with the switch, and on the switch you configure a monitor span session, which says that any traffic coming in or out of that particular interface, redirect it or make a copy of it to on the switch and forward it out of a certain interface where your laptop is connected. This will help you capture all the traffic and understand the flow of packets between the two devices, right? So this is really helpful. Different environments, different code bases have different support for it. There are some internal softwares as well that can be used. Here's RSpan as well. If you do not have, if your PC where your Wireshark is installed is located somewhere remotely, say 10 hops away or 15 hops away, you can use remote span, wherein you specify a source one at one place. You will have to make some configurations on middle nodes as well, but you can capture the packets remotely. It's in a generally used in an environment where you have pre-decided where you want to have permanently have your Wireshark capturing PC, and based on that you can use our span feature. But most of the times regular span features are used. And this is how it looks like. You can look at the packets level and understand what is going on, which packet is coming in from which IP, source IP and destination, and what kind of packet is coming in. And based on that, you can understand where the problem lies. Okay, this is just for your reference. There are certain platform level captures that you can perform on the router itself. You don't need an external Wireshark tool. If you're working on any of these platforms, you can use those inbuilt iOS or ISX or Nexus softwares which capture the packet on the router itself. Those are really helpful when we are performing any platform level troubleshooting. We use that in a day-to-day life. More details about this can be found on a Cisco Live session. I have mentioned the reference for that in the notes window. You can refer to that. All right. So moving to the next session, that is the scenario that is of missing routes. I hope I'm not going too fast. BGP is really a vast protocol, and it is really hard to cover that in 1 hour. But if you still have any questions at any point of your presentation or anything apart from the presentation, do not feel to post your questions on Ask the Expert, and I'll try to answer them as much as I can. All right, coming back to the missing routes. So there are update filterings, like you mentioned before. They can happen on multiple. You can install or configure multiple kind of filters. You have prefix filters, you have AS path filters, you have community-based filters, and you have route maps based on different attributes or IP addresses. You match and set conditions. You do the filtering, right? And those filtering can be applied in and out direction. So here's a scenario. You have two routers, router 1 and router 2, okay? So here, I'll be needing all of your help. Use the Q&A or the Q&A panel, wherein you can post your answers when I ask the question so that we can troubleshoot all together, okay? So R1 and R2. So R1 is advertising. R2 is advertising prefix 10.1.1.0/24. But when you check it on R1, show IP BGP neighbor 2.2.2.2 routes, you see 0 prefixes. You don't see any prefixes. If you already know a specific prefix, you can use the command show IP BGP 10.1.1.0 to see how the prefix looks like. But here, if you notice, there are no prefixes being received from R2. So what do? You go to R2, right? So what do we see here? Show run begin BGP. We see that the network statement is configured, and we are setting a community value. So we say network statement, route map, set community. This is the route map name, and you notice that route map set community has the statement set community 2:2 and 1:50. Right? And you can also look at the prefix, and you can see the same value attached over here. Okay? Now R1 is filtering those routes based on the community value. Let's look at R1. Okay, so this is how the configuration looks on R2. I'll move on to the R1 configuration. So let's look at the R1 configuration. So R1 says R1 2.2.2.2 route map, and it says R1 out, and it says match community, and it sets the local preference. So if you notice, the community list is configured. Now, can you say what is missing in this configuration, or what wrong is there in the configuration? I will rely on your outputs into that. So somebody mentioned that yes, the network is advertised on R2. Okay, because R2 do not have subnet. So R2 does have the subnet in its routing table and the BGP table. What else? Any other inputs? Oh, perfect. So Jeffrey, I see, has mentioned that the R1 community list does not match the community on R2. Interesting, very interesting, right? Notice that sometimes a typo error happens when you are typing the community values. We configured the community value of 2:2, 1:50. But here, we are configuring 1:150 as a match statement. So it's matching either of those community values, but 1:150 is not the correct match. So it's not correct, right? So you need to ensure that you're configuring the correct community values when you're configuring community, okay? All right. So community match on R1 expects 1:150, but R2 is sending 1:50, right? So R2 is not receiving those routes. So what if? I mean, I've given an example on how you can use the match statements, or how the flow within the code happens when you're using the match statements in route maps. So it's like if match certain statement, set and exit route map. If the first match statement doesn't matches, move to the next match statement or another sequence of the route map, right? That's how you look at the route maps. Okay, so if you are still not able to receive the routes on R1, here's a quick way you can run conditional debugs. Now, if you run a regular debug IP BGP 2.2.2, debug IP BGP, and for a particular neighbor, you will receive whole lot of updates. Say for you are advertising from R2, 1,000 prefixes. So you will get the update for all those 1,000 prefixes, but you don't want that. You're troubleshooting only a particular prefix. So create an ACL, specify the subnet you're troubleshooting, okay, and use that ACL while running the debug. So run debug IP BGP, neighbor IP, update, and the ACL name. A lot of Cisco iOS softwares and even ISXR supports running the conditional debugs. This really helps minimizing the debug output and having less impact on the router, right? One other quick note that I want to make here is if you look at the configuration in this scenario, the routes might still not be advertised or received on R1 router, right? And the reason is because you are forgetting to use the command send community. If you're not using send community command, community value is not attached or advertised to the peer. So you need to use that, okay? Just wanted to give you a brief on that as well. So these are the two scenarios that are that I'm covering today. There are more different scenarios, but due to the time constraint, I cannot really cover all of them. There are reference sections wherein I have given the link for the RFC. Initially, you can refer to the configuration guide and the troubleshooting BGP document on Cisco to see how the protocol functions and how you can configure it. But if you want to go really deep into BGP, I would suggest after you have read this, go read the RFC because it gives you a much better understanding of the protocol itself. Okay. That's it from my side. Monica, over to you.
Sure, thank you. Probably you want to mute, Vinit. So thank you and great presentation, Vinit. Also, thanks everyone for participating in the every polling. It was very active. Now it is time to answer some of the technical questions that you guys have. If you cannot stay with us for the Q&A, please be sure to click on the evaluation link that will appear when you close the event window, and let us know how this session met your business needs and expectations, right? Now, starting with the first question, Vinit, is which protocol should we use within an AS? Should we use IGP or BGP?
So it totally depends. If you're not having any external BGP or external connections with a different AS number, and if you are not having a huge scale environment, I would suggest just running an IGP should be fine. But if you are running different services, like say for a lot of enterprises have now moved to using MPLS VPN into their enterprise environment within the autonomous system. So in that scenario, it is good to have BGP. Well, BGP also gives you more control over how you want to influence your traffic. So you can use that as well. So it totally depends. But you can run BGP on top of IGP as well.
Okay.
Within your environment.
Perfect. And the next question is, can we secure BGP connections like IGP?
Yes, so BGP supports connection using or securing the connection using MD5 authentication. There are different techniques you can secure a BGP connection. Say for what you can do is you can have a BGP session established over an IPsec tunnel or IPsec session that will help you secure all the messages exchanged between the two neighbors. Well, you cannot run IPsec everywhere. It's generally when you're running between two remote locations or two different sites. It's where you generally prefer to have your IPsec tunnel. But otherwise, you can still secure a connection using MD5 authentication, wherein a hash is generated and exchanged between the neighbors based on the pre-shared key, and a session is established.
Perfect. Yeah. We got another one. How many BGP neighbors can we configure on a router?
It totally depends on the scale of the router, how much memory, and what kind of CPU are you using. Say for a router is behaving as a route reflector, wherein the route reflector router has multiple neighborships or sessions with it. It can literally scale up to thousands of neighbors, but it again depends on what amount of memory you have on the router. It is better to know the scale of the platform before you configure the extended number of BGP neighbors on that platform.
Perfect. Good. Let me just remind the audience that they can keep posting their technical questions, and we will be having here like another 10 minutes, like another 20 minutes of being able to answer your questions. The next question, Vinit, is can we have 2 or more BGP connections between 2 peers?
Not on the same IP. So you can have different loopbacks configured between the 2 BGP neighbors. So if I understand the question properly, is that can we have 2 or more neighborships between same 2 peers, right? For that, you can have multiple loopback addresses configured on both sides, and you can peer or you can have multiple connections over those different loopback addresses. But on the same IP, you can only have one connection. But you can have connection on different address family, but within the same address family, you can only have one connection.
Perfect. Yeah. And is it load balancing possible in BGP?
Yes. So BGP supports advertising multiple paths, via which the other end gets to know about the prefixes being learned via 2 paths, and you can use for load balancing purposes.
Sweet. Perfect. And then we have another question: is why do we need full mesh BGP sessions within NIS?
Sorry, can you repeat that question again, please?
Why do we need a full mesh BGP sessions within an AS, like an autonomous system?
Okay, so the question is why do we need a full mesh? Now, remember in the presentation I said that IBGP routes cannot be advertised to another IBGP routes. Why? Because the loop prevention mechanism will block the AS from receiving or learning the route and or installing in its BGP table, right? So in order to overcome that, you can have full mesh connections to all the neighbors so that you don't have to rely on any of one particular BGP neighbor to advertise it to its another peer. Alternatively, you can have that behavior achieved using route reflector, but there can be, all the neighbors will be connecting to the route reflector, not with each other. So either way you can achieve it, but a scalable way is to use route reflectors.
Perfect. The next question is, what is the use of MED?
Use of MED. So it's kind of a metric like we have in our IGPs. It's again used as an attribute and used to influence the traffic.
Perfect. And
so between different ASs, for sure.
Correct. And can we advertise subnets less than 24 subnet mask?
Yes, we can.
And what is the role of a router ID on BGP?
So router ID really helps kind of making uniquely identify a particular router, but at the same time, it is some information that is exchanged between the BGP peers as well. It is good practice to configure the loopback addresses as the router ID. That has been recommended throughout, that you configure your loopback addresses and form your peerings as well, especially the IBGP peerings over your loopback, so that you know how to reach a particular router within your network. But apart from that, it's not really required for forming any kind of BGP neighborship.
Okay, and what is the meaning of prefix in BGP?
So prefix is something that is advertised to a peer. it becomes a route when it's selected as the best and installed in the routing table.
Perfect. And why are we using OSPF and IBGP both are the same IGP?
Okay, so here's the thing. If you notice the IBGP configuration, we did the peering, and I'm really sorry that the screen was not refreshing on WebEx. I was out of my control, but when we are using peering via loopback addresses, you need to have the loopback reachability, right? Your base IGP provides that loopback to loopback reachability. You can also have static routes, but if you have, say, for within your autonomous system environment, you have hundreds of routers, it is not really a scalable way to run static routes everywhere, right? The better option is to configure an IGP within those 100 routers within your autonomous system, via which you can have reachability to all of the loopbacks. The benefit is it's not necessary you want to form an IBGP connection between two directly connected routers. You can form an IBGP connection between router A and router Z, or router Z, which is sitting like 20 hops away, 25, 100 hops away, no matter what. You can still form the BGP connection.
Perfect. And then another question is how to see the BGP route coming from a BGP peer?
So show IP BGP neighbor IP routes. Another way is if you configure soft reconfiguration inbound for a particular neighbor, it maintains another table within the memory, and you can see what routes you're receiving using the command show IP BGP neighbor IP received routes. You cannot use the command received routes without configuring soft reconfiguration inbound. But remember, soft reconfiguration inbound has its downside that it consumes more memory for BGP because it maintains a separate table.
Okay, perfect. And then the next question is why it is recommended to use router ID when configuring BGP? It kind of have to do with the previous question as well.
All right, so why it is recommended is that, say for you're not using you're using different address families, right? And say for you're using VRFs. So it becomes difficult if you're using VRF light condition to identify which IP is the router ID or which router it is exactly, unless you are describing it in a description. The better way is using router ID, you can identify a particular node properly, and it makes it really simpler for manageability of the network.
Okay. The next question is, can you please talk about more detail about the family address?
Okay, so address family is like now we already know that IPv4 addresses are getting depleted. IPv6 is taking pace. So routing protocols, a lot of routing protocols already support both IPv4 and IPv6. And the systems already support dual stack, that is both IPv4, IPv6. So address families help you provide a benefit of using the same routing process to connect or to form neighborship with neighbors using different address spaces, be it IPv4, be it IPv6. Within the address families, your sessions are only dedicated to that address families, and you don't have to worry about, so it may be possible that your session to a particular router is only for a particular address family, and you don't form a neighborship to other IPv4. So router A and B forming neighborship over IPv6, and router A and C forming neighborship over IPv4. They can have their own different address families, and they cannot have their information exchanged within that routing information base of that address family. And based on the address family, again, the information that you receive is stored in the local IPv4 or IPv6 routing address families, routing tables.
We have 5 more minutes to go. Another question is, what are communities? What are they used for?
So communities are you can take it as route tags. So you assign tags, and those tags can be useful to match the communities and to take certain actions on them. There are some predefined communities. Those have their predefined notions on what they are supposed to do, and you cannot change their behavior. But there are other communities which can be manually configured or manually assigned as per your own AS number values or your internal blueprints of your network design, and you can manipulate the routing based on those community values. So it's actually useful when you want to, control or influence the routing based on the match statements.
Perfect. And then another question came in, what are the disadvantages of BGP securing mechanisms?
Well, it's a wide question. Disadvantage is that it consumes some amount of bytes in the memory. It depends what mechanism you are implementing. There are a huge set of mechanisms that are available for securing BGP, like IPsec I mentioned, right? So with IPsec, the IPsec header consumes some number of bytes, which are gone. So you cannot transfer or cannot make full use of the interface bandwidth. Say for an interface bandwidth of 1500 bytes, when you are using IPsec tunnel and with GRE, you drill down to 1380 bytes or something, that sort of value. That reduces the maximum exchange segment size between your two neighbors. That is one example. With MD5 authentication, the only downside comes in when you are not, or when there are typo issues, or when you are using dynamic peerings. Otherwise, there isn't much downside with MD5.
Perfect. Another one is, as a customer, how can we check how many ISPs have set?
I didn't really get the question. As a customer, how can we check how many ISPs?
Yeah, how many ISP have set on the configuration?
Oh, how many ISPs? So you need to look at your WAN connections and if you look at the show IP BGP Summary command output, you will notice the peering IPs. And those peering IPs, if you are able to locate it or match it with your WAN interface IPs, you will come to know that those are your external WAN connections or with your service provider. That will help you understand that. I mean, you can always differentiate between your private addresses and your public addresses, right? So that is how you can differentiate that way.
Yeah. Cool. Another one is how to remove private IS from a path.
There is a command, remove private AS with a particular neighbor. You can configure that, and that will remove the private AS numbers. If I would prefer this question posted on the Ask the Expert forum, because it was a lot of folks don't know about this one, so yeah, you can still post it and we can discuss it again.
Perfect. Yes. Yes. And then another question is, what is the advantage of using AS path over local preference when configuring BGP to prefer one path over another?
So, like I said before, there was a slide which mentions that influencing the inbound traffic and the outbound traffic. Your local preference is influencing the outbound traffic. Your AS path, you decide upon which path is going to be preferred, right? From where you want a particular traffic to enter into the autonomous system. You can use that. AS path, the one benefit I can see is the AS path is a default or mandatory attribute. So if you do anything with that, it is obviously prepend statement is going to add some more memory to it, but it's again an action on a default attribute. So you're not configuring any extra attribute, so save some memory there.
Perfect. And the next question is, can I run BGP on an IPv6 only network?
Yes, you can.
Perfect. Then the next question is, does it matter which router is the server when BGP TCP session is established?
It totally depends on your what is your router ID and your lowest and highest IP addresses.
Perfect. Then the next question is, can you comment on use of route tags in BGP and in OSPF? So the question is, can I set a tag in BGP route, then match that tag on redistribution into OSPF?
I don't think you can do that, but I think you can do the other way around, wherein you can match a tag in OSPF, and while redistributing OSPF into BGP, you can match the tag.
Okay, cool.
But I will have to check again on that. I can get back to you on that.
Sure. We have time for a few more questions. This one is referring to MPLS VPNs. And the question is, do you recommend IBGP for PE to CE connection or extend that over OSPF?
For P to C, it totally depends on what the C requirement is. Obviously, it is not a good practice to run IBGP because there's a new RFC that has been introduced that says that you can use IBGP between P and C, which logically should be an eBGP connection, but it is not really a good practice according to me. You can use any other routing protocol, but on top of that, again, it totally depends on your CE router, what they support, and what the requirements are.
Good, good. Another question is, what is the use of no synchronization command on BGP?
Non-synchronization command, for this one, I would say I will post you a document or a blog post which explains it in a good way, because you'll understand it in a better way when you have a good example of how the BGP table looks with and without the configuration command. I can do that. If you can post your question on the Ask the Expert, I'll explain you with the help of an example in a much better way.
Okay, let me just. Another question comes is, what attributes do I lose when I redistribute BGP into OSPF?
So I don't think any of those attributes are copied. Any of the BGP attributes are copied into OSPF, right? You only, when you redistribute based on your redistributing protocol into which you are redistributing. So you say that when you're redistributing into OSPF, you say what is the subnets that you want to allow, or redistributing OSPF process name and subnets, or without subnets, or you want to use a route map to match any prefixes. But I don't think any attributes will be copied, because both the attributes on BGP and OSPF are different.
Perfect. And we have time for just one more question, and this is for MPLS. What IGP do you recommend to use when running MPLS?
Again, this would depend on how big is your environment. Both ISIS and OSPF have been pretty stable. I wouldn't recommend anything apart from those, because with OSPF and ISIS, you have the flexibility of implementing traffic engineering, which is really good to use to control or to engineer your traffic within your autonomous system or your whole network. So though you can still run MPLS on top of EIGRP, but it's not a good practice.
Perfect. Well, thank you. This concludes the Q&A portion. We will have, Vinit will continue to answer questions in this Ask the Expert event from now until the 22nd. So please feel free to continue asking your questions there. Also, we have a lot of social media channels where you can collaborate and be friends with. And we have Facebook, Twitter, YouTube, Google+, LinkedIn, Instagram, and you can also subscribe to the newsletter that we send monthly, where you can learn about all these events and many other things. And all the links are on the chat for you to use. We continue to expand in many different languages, and we have 5 different languages: Spanish, Portuguese, Japanese, Russian, and Chinese. So if you speak any of those languages, we invite you to participate in your own language. And I have put the links on the chat for each of the local languages there, so that you can help yourself on any of these languages if you speak them. Also, if you are looking for more information on IT and technical training, log on to the Cisco Learning Network and take advantage of the technical webinars that they offer. So you can go to the link that is posted on the chat. And then, as appreciation for having attended this event, you can redeem your 35% discount at Cisco Press, and you can buy any of the Cisco Press books by entering the code CSC, capital letters, when you are checking out. So you can redeem your code at the link posted in the chat. So please take advantage of this offer. Any of the books have a 35% discount when you put in that code. So before signing off, please take a few minutes to complete your evaluation in today's session. This will help us to address your business needs and interests in the future, and we take the feedback very seriously. And this concludes our session today. Thanks a lot to Vinit for sharing his expertise, and also thanks to Brian and Manish for answering many of the technical questions. You have a great day, and see you in the Cisco support community.
Hey, thanks, Monica. Thanks, everyone, for joining in. And feel free to post your questions, and I'll try to answer them as much as I can.
Thank you, everyone.
Hey, thank you.